Hey, John here. I'm just messing around with the Rev4 drawings here, the schematic for the Z80 Retro board. This has been like up here for like 3 months, and no one's commented since I made the last modifications here. What I'm doing right now is I'm tinkering around with how the flash, the unused pins, and the high order address lines on the flash work. Now, somebody posted a note asking if I could put a jumper in here like this so that if they wanted to, they could put two different images in the flash, from 0 up to 64K in the flash address space, and then from the 64K to the 128K, and then they could put this jumper in or take it out, and they could use that to choose two different boot images if they want. Well, I certainly don't want to stand in the way of any kind of creativity along those lines, so I say, sure, I'll go ahead and put that in there. Now, while we're playing around in here, there is some other things that it's just been gnawing at me this whole time. I've never released revision 4, and it's because of this. If you decide, and this is really a thing right now with the chip shortage going on right now, if you want to use some different chips, or you actually want to put a real UV EEPROM or something in there, it would work, but these pins might not be able to. You may want to pull, pin 1 up to 5 volts instead of ground or something like that. And there's not a lot of room left on the board. There's just not enough real estate. So while the jumper is a good idea and there's enough room for it, why not? Just put it in there. If you don't want the jumper, don't put it in. It doesn't matter. This resistor here, R14, pulls A16 to ground anyway, and the way this design used to work in Rev 3, all 3 of these pins were just shorted together and run to ground, which is perfectly fine for this particular flash chip, okay? But if you ended up with an EEPROM, it might not work, okay? So I wanted to free up these pins and give you some traces and stuff. You can go in there with an X-Acto knife if you wanted to cut the traces in order to disconnect these pins from ground, and then reach in there with some little, like some little teeny wire wrap wires or something, and wire them up to whatever you want to do with them, okay? I mean, absolutely. Don't get in the way. So let's look and see what I'm doing right here. I'm wrapping this up right now. These things here are called net tie, all right? Not neck tie, but net as in N-E-T. So if I go in here and I type in tie, I got a video. Oops, that's not what I wanted to do. I got a video on net ties in my KiCad series. If you look in here, like there's a net tie 2, you see this thing? That's what I put in there. So it's just 2 pins that are connected by a wire. So what happens is this allows KiCad not to get confused and not to do us any favors that we don't want it to do. And that means that the net here, this wire that connects pin 30 over to this thing, is completely independent and different than the net that is on the other end of this part. Okay, and wherever it goes, which is to ground. But since this is just copper, what this really means is the same thing as just connecting it up to these 2 pins. However, when you get to the PC board and zoom in on these, so I've already placed one, and the other one's sitting over here, right? NT2 over there. Let's see what I did with NT1, all right? What I did with NT1 is I stuck it on pin 30 here, and just let it stick out. One end of this is ground, and the other end is connected to pin 30, all right? So if we turn on the polygons here, look what's going on. So this pin, without the net tie, if I just connect it to ground in the schematic, what happens is the copper flows into this pad on the top and the back layer, as well as the inner layer that's ground. So if you really wanted to cut, that pin and connect it to something else, you really can't do it. You'd almost have to drill the hole out in the board. Hey, we don't want to do that. That's just pointless. Short-sighted, okay? I apologize. My bad. So what I did here for one of the mods for revision 4 is I'm going to put this net tie, which is this little piece of copper right here that connects it to ground. And then when you're done, let's hit Alt-3 here. And you flip over this board. I mean, you can see it in the regular schematic. There's my flash. There it is right there. So you can go in here with an X-Acto knife or something and cut this and disconnect that pin. All right. Now, the reason I want it connected to ground, I was thinking about just letting the thing float. I could, if you get the parts that I use. Let's look at the bill of materials here. If you grab the flash that I used, whatever that is, something, is that it? No, this is it right here. Okay, so let's look at the data sheet here. You can get a 1 meg, 2 meg, or a 4 meg. Okay. Now, right now, as I type, the 1 meg in the through-hole parts are out of stock at DigiKey. But they have a 2 meg part. Let's look at the pinouts here. What's the difference between the 1 meg and the 2 meg parts? Well, the 1 meg is this FO10, the 2 meg is the 20, and the 4 meg is the 40. The only difference is what happens to pins 30 and pins 1. Okay? Now, in the 16 meg part, pins 1 and 30 are completely disconnected. When you go up to 2 meg, pin 1 is still disconnected, but this one has to go to A17. Now, if you just want your board to work and you don't care about paying an extra quarter for the bigger sized flash, you want A17 connected to the ground, okay? But it turns out that pins like 30, 31, 32, pin 1 here, these things have a tendency to be repurposed for different things when you get an EEPROM in there, a UV erasable one. So by using a net tie on pin 30 and running it to ground, that means A17 would be 0, which is exactly what you want if you have the bigger parts, all right? Same thing with A18 if you just wanted to use the bottom 64K and ignore the rest of it, okay? Now, the jumper is on A16 that I'm adding. So it used to be that A16, pin 1, and pin 30, which would be 16, 17, and 18, used to all be just connected to ground, so you could use any one of the 3 sizes in the same configuration. It would always work with the in-circuit flash programmer and everything, okay? But if you don't want to use it that way and you want to tinker around, that's why I wanted to redesign the copper so you can go in there with an X-Acto knife and cut these tracks and do anything you want with them, all right? So that's the goal here. So doing pin 30 with a little thingy like this is exactly what you would want, all right? Same thing on pin 1. So let me show you about this because these things are kind of weird. I'm not really happy with how KiCad deals with these, and I want you to see what happens if you decide to play around with these, all right? Okay, so here this one wants to connect to pin 1. I'm going to just put it like this. Now, it's on the front of the board. Let's turn off the polygons for a minute. I want to put it on the back, right? Why am I putting it on the back? So that after you put your entire board together and completely forgot about this, you can get your knife in there. If I put this on the front of the board, the socket or the chip would be in your way, okay? So on the back copper, okay, I don't want to see this part ID, so I'm going to go in here and I'm going to say turn it off. I don't want to see it. No one cares, okay? I think I shut the other one off as well. Yes, that is off. And it doesn't say NT1 anywhere, all right? Now, as drawn, the ground half of this pin is not connected anymore. So let's turn on the polygons again and hit B to repour the polygons. And look what happens here. What happens? I have it backwards. It says ground on one end, pin 2 of the net tie. So let's go ahead and rotate it around. It was backwards because when I flipped it over with the F command to put it on the back of the PC board, it ended up rotating and flipping it over like this. So it's B again, repour the polygons, and this is what gets me nuts here. So on the back copper, I selected something. See what it's doing with the clearance settings that I have. It's confused as to how to pour this thing, all right? So this is what I'm wasting your time because I want you to see this. If you do this, I'm going to hit X to pour a track here. Now, if you just run this up like that, you probably cover it. But what I'm going to do is I'm going to edit this thing and make it 0.5, a half a millimeter. And I'm going to do just same thing, but a little bit fatter track, okay? So I've just drawn a line, some copper in there. I'm going to hit B and let it fill. Now, I don't understand why this line is drawing across here. It suggests that it is not connected. Let's see. Here, turn off the polygons. Maybe it just needs to go a little bit further. So I'm going to hit, what I'm going to hit here, D, and I'm going to bring it up a little bit further. Yeah, it stopped. It probably was upset because the dot in here, let's hit Control Z and move it back down here. It's probably upset when it's not pulled very far because this center here, which is considered the point where the end of that track is, was probably, let's turn the polygons back on. It's inside here. Let me just hit Control Z again. See how the polygon doesn't fill right here? Well, when I drew that track, the end of the track was probably there and was disconnected as far as KiCad was concerned. So if I do it again, let's go ahead and shut off this polygon here, grab the track and hit D, move it up here to where the polygon really is, and resave it all and turn the polygon. Now it's happy. Okay, so that's what was going on with that. So now if I Alt 3 again and we take a look at the board and the photo view, somebody can go in here, like I said, with an X-Acto on both of those two pins. Here's pin 1. You see this little thing right there? You can get that in. You can get in there and cut it. And the same thing with the pin 30 over here. All right. And then if you decide you don't want them grounded, that's what you'll do. You cut it off. You might take a little piece of wire on there and then run it up to one of the pins around here. It turns out this is a bypass cap. These are the pins on a bypass cap. So it turns out this is grounded and this is on VCC. So if you really wanted them, instead of going to ground, you wanted them to go to +5, you could just solder a little wire up around like that, okay? So that's what's going on with those net ties. So I got a great memory. Ooh, I'm going to remember everything I did. Not, especially over 3 months. I made changes. What did I really do? Well, I wrote this little script right here. Let's look and see what this thing does. This is going to play some games with Git, and there might be a better way to do this. Please let me know in the comments below. I'm tinkering around with this morning to try and simplify it and not make a disaster here. But the short of this is I have these two Git versions. So if you type Git tag, right? So we just marked version 4 release candidate number 1 here. After I made these changes, I went ahead and added them all and committed them, generated the Gerbers and all that other fun stuff, and put a tag in my GitHub repo over here. So if you go into the project, there's now going to be the two patches here. So version 3 and here's version 4 release candidate number 1. Which is the one that I just created with the net ties in it, okay? So let's look at how we can ask what really changed. So there's the schematic drawing, and then there's the PC board copper, okay? Now look what's going on here. I'm not going to get into all the details of Git and everything else, but the short of it is there's this command git show that says, I want to see this file from this tagged version in my Git repo. And I want you to save it in a temporary file over here. I'm going to grab the front and back coppers from version A. So we set version A is version 3. And version B is going to be, version 4, release candidate number 1. The two tags, right? If I type git tag, we should see them in there right there, okay? There's the version 3 and 4, okay? You type git log, and you can see what you said about them, but you really want to know, did I screw up the copper and all that stuff? So let's go ahead and look at what I'm doing here. All right, so grab me the front and back Gerber, and grab me the PDF version of the schematic in version A. I want to differentiate between version A and version B, okay? So I do the same thing for version B. Give me the front and back copper and the PDF of the schematic drawing. Then I use this command called compare, which is part of the ImageMagick package. You can run this on Windows. You can run it on Linux and stuff like that. ImageMagick is pretty widely available. This script, of course, is only going to run on a Unix-like system, like Linux. You can run it on your Pi or, any desktop, Linux box, or WSL for that matter. And what this is going to do is it's going to say, look, here's a PDF file, which is my version A. And here's another PDF file, which is my version B. And I want you to generate a new one highlighting the differences between those two files and save it in this file over here, which is going to be, my version A versus version B Delta PDF file, all right? I can do a similar thing with the Gerbers, although ImageMagick doesn't know how to read in a Gerber, so I just use Gerber View or GerbV, and I generate a ping file called this, all right, a temporary ping file from the top and bottom layers from version A. Okay, this is actually going to generate the two layers together in one ping. Then I'm going to do another one for version B. And again, I can run a compare again. Compare knows how to do PDFs. It knows how to do pings. So I just give it, here's version A's ping and version B's ping. And generate the same kind of a thing. But this time I'm going to generate a ping file. And then I delete all my scratch files down there. So here's the deal. If you're in your Git repo and you're up to date and you're on the main branch and you want to see what the difference is between the two versions we just looked at, you might need to change the script here to change the tag down there. Maybe you want to set it to main. If you make changes, you check this repo out, you make a bunch of modifications, you could change this to main and it would differentiate between main and version 3. Or, you could make a tag could be version 4 or version main or whatever two versions you want to do in, GitHub, Git speak, right? So we then run this script. And it's going to generate some files, and it'll clobber some files that are in this directory, and that's okay for just for discussion purposes. It generated a new Delta PDF and a new Delta ping. So let's look at these files here. Now on my desktop, I use events to look at my PDF files, and it decided to put it off the screen. There you go. And this is what I get. This is a PDF that shows the differences between the two different PDFs I've saved in the two different versions. And what we got here, I changed the symbol for the NAND gate in the reset circuit. I talked along about that a while ago, and while the bill of materials had the right part and so on in it, the problem was the schematic did not have the Schmidt trigger marker on the NAND gate. Okay, so I changed the symbol in KeyKit. I didn't change the schematic, didn't change the meaning, didn't change the BOM. What I did is I changed the drawing so that it showed correctly. So that's why this is going to be highlighted, and the other three gates on the same chip, one of which is down here, and the other two are over here, all show up, okay? Look at the other red stuff. Here's me clowning around with the address lines of the no connect. All the stuff that's red in here tells you what to look at in the schematics. Now I can open up the two PDFs, the version 3 PDF, the version 4 PDF, and it says, look here, look here, look here, look over here, and so on. All right? So why did some of these things change? Well, these things changed because the BOM said to use HC parts, and the schematic was drawn with like LS parts or something like that. So I changed the part names in the drawing here to match the as-built board that I created for my own version 3 board. So I updated those to match what I was doing. And these are the power lines for the chips whose part names were changed to match the BOM as well. For some reason, these changed. I don't remember changing the name. This is the Z80 and the CTC. Those didn't change. I may have bumped where this was in the schematic. So I mean, remember, this is a visual diff purely on a per pixel basis. So these things changed probably because I moved them or nudged them. All right. The other changes in here, I changed the size of a capacitor over here because I think I talked about this before. One of my power supplies boots up in a weird way, and my board wouldn't come out of reset correctly. So I changed a 0.1 microfarad capacitor to a 0.47. This doesn't change your ability to press the button or anything like that, and it only happens on one of my power supplies. But I figured, maybe it would mess up with other people as well, so I made it a point to change that to a 0.47. Here are the terminating resistors that I added to the schematic. These things address and I'm looking at the clock that comes out of the baud rate oscillator and the main system clock, and these signals kind of overshoot a little bit when I look at them on my scope, and I didn't really like that. I figured I'll terminate these with some 120 ohm resistors, and there's no board real estate right next to the oscillator cans. I mean, optimally, it would have been better to put a series resistor in there, physically really close to the oscillator. It would probably have been the right way to do this, but I didn't have space. And while mine works fine for more than 3 months, 24/7, it's probably fine, but this helps a little bit. It's better than nothing. And it was easy enough to add these. There was space for them, so I went ahead and put them in there if you want to play around with that. Otherwise, you can just leave them out, and it's the same thing as version 3. This red mark here is, I put a note in here. I said, or there's like a BCT, something or other. There's if you can't buy the transistor I spec'd, I say, here's another one. And I put that in the drawing just for reference, all right? So that shows up. Here's the line over here that is the difference between the hooking up the printer to the, what was that? It used to go to the, RTSA, and I changed it over to DTRB, okay? So this tells you not necessarily what changed, but tells you where to look. You open up the version 3, open up the version 4, and this is right in your face. You can see what changed, all right? Now, this is pretty straightforward. Yeah, if you forget, there it is. Not going to be a problem. Now, let's look at this ping file. This is, in my opinion, a little more critical. And once again, it decides to open in the middle of nowhere. Let me fix that so we can all see it here. All right, so this is the difference between the image of the top and bottom copper layers. I didn't do the middle because they're just ground planes and power planes anyway. So I wanted to see what changed. Make sure I got it all right, okay? This down here is me adding some extra copper to the 5-volt line coming off the USB connector. I mean, months ago, I was tinkering with this and thinking out loud, hey, I probably should add more copper over here. Well, while I'm playing around, there it is. I put some more copper rather than just having these 3 vias connecting the power pin to the middle layer in the board. I put a big hefty amount of copper going to some other through holes that have soldered pins in them. So this should do a better job at making sure that there's not a potential, high impedance connection in there. It would have been, I'm sure it's fine. My Rev 3 board, like I said, I've been running for months. I don't have any trouble with it, but this is, 10 tons of sledgehammer overkill to make sure that we have more than enough copper connecting up the power to that middle layer. Over here, we see the traces that differentiate between the connecting the DTRA versus, RTSA rather, versus DTRB. That's the track over here. It used to go to the pin on this side. I disconnected it and I reran it over to a pin on the other side. And in doing so, I had to move a few things around. That doesn't look too bad, all right? This giant line up in here is probably, when I was poking around in there, what this is showing is that there didn't used to be ground fill between these 2 tracks, and now there is. Okay? And again, you can just go ahead and open up the version 3 Gerbers and the version 4 and zoom in this area and see what's different. Okay? Here's another area that did not used to have ground, and I wanted ground, so I put a via or something in there. This track up here is the end of the baud rate clock that runs up to a resistor that's up here. This is the new resistor, the 150 ohm resistor that I added, okay? And when I put this in here, I probably had to move another part to get it out of the way, which is why there's a few other changes in this general vicinity. This over here is me playing around. You can actually see the little cutaway tie right there. That's on the pin, what is that, pin 1 it looks like, because it's a square pad on the flash chip here. And there's pin, I guess it was 30 or something like that, where the other one was. So you would expect to see changes around pin 30 and pin 1. This over here is the difference in the ground plane disappearing or being added during the 2 different versions of the board. If it went away, I'm not that concerned about it, because the ground and the power is in the middle planes of the board anyway. The track that goes up here, there's the new jumper. Okay, and the track that goes over here, this is the resistor that pulls up, or rather down in this case, that A16 value. You can see I ran a track over there to deal with that, to pull down the signal. So if you don't have the jumper in here, it pulls it to ground, which is the same as it was in version 3 of the design. Here's the new resistor that I added to pull down, or terminate the clock, the system clock. So I added a track that comes around here to come up to this resistor so we can terminate that. Okay, so these are the differences in the copper. And this is, I want to make sure that you all saw this, because if you decide to play around with this thing or make some small changes and you want to know, to what extent did I change, the copper and stuff like that. So you can play around with this script and these commands like that. You could probably change, these 2 tag names. And remember, these are the tag names from Git. So if you type git tag, it'll tell you what they are. I think what is it, tag, what is it, minus like N6 or something, will give you the messages that I put on those tags as well. And one of the tags that exists in all repos is main, right? Or whatever you called your main branch. So the branch names are also valid, for this purpose here. So my point is, if I wanted to, I could put main in here for one of these tags as well. So if you wanted to see version 3 versus main, just change that to main, run the script again, generate your files, and have a look-see at them. All right, so this is a summary of the differences between version 3 and version 4. If you already have a version 3, don't freak out. There's the only thing that really happened in here that might have any impact at all is if your printer doesn't work correctly because of the fact that the line feed signal is glitching or something like that. You might want to upgrade to version 4 for that, but this is cosmetic mostly, and features that I don't plan to use the extra jumper. Somebody asked for that, like I said earlier, so I put it in there while I was poking around and said, all right, fine, let's go ahead and get ready for a release. Now, I'm not really releasing version 4 here. I'd like to hear everybody's opinions on this sort of stuff. Is there anything overwhelmingly annoying to anybody in there? Let me know. Before we go ahead and do a formal release of this thing. Plus, I'd like to actually build one before I tell anybody that it will actually work. But we just looked at the Gerbers. It looks pretty good. It's probably fine. So anyway, have at it, have fun. Thanks for watching. I'll see you next time.